So today, the topic for today is top 5 algorithms used in data science. So there are different algorithms. We have picked the ones which we thought was very relevant, and it is being used frequently. There are so many algorithms in data science. So we will see the top 5 algorithms here, right? So I may not have too much time to discuss the algorithms in detail, but how much ever I'll try my best to have it covered, friends. Yeah, thank you so much. So just moving on to the next slides. Um, End of the session, yeah, you'll be able to understand what is data science, what do the data scientists do, and top 5 algorithms. We have picked a decision tree, random forest, association, rule mining, linear regression, and k-means. So I'll try to show you a demo on k-means clustering as well. Yeah. So this is the agenda for today. And looking at data science, friends, you're dropping your numbers. If you just look at the cartoon, uh, it is undoubtedly, it is becoming, and it has already become the sexiest job of the 21st century. Uh, Data scientists are creating waves around the world, and because data is making a lot of sense these days, and people don't, any decision has to be backed by very strong data, correct? Backed by very strong data, correct? So, and there are very few people who can actually defy that whole process of uh, what to say, just making a, yeah, like Steve Jobs, right? If you all remember, he didn't go by the principles of data and all. He rather decided, he decided that what people would like, what people would want, he decided, right? The market. Not everybody is like that. That's like a 1 in a billion case. But whatever you talk, any facts today, there are very famous quotes and quotations from from the internet and all that. If you see that, they say, we just believe in God. The rest of the things has to be backed by data. It has come to that stage today, right? So things are very, very prevalent today with data and all that. So it's very important that everything has to be done through data, friends. Yeah. So data scientists play a very major role here, because they end up doing lots and lots of analysis and come up with a lot of insights, and that insights are getting translated to major product decisions that even changes the course of the company, right? So today, things have come a very long way today. Yeah. So what is data science? If you see, it is nothing but extracting meaningful and actionable knowledge from data. Like if you just go back few years back or few decades back, right? It was all gold rush to start with, right? People began with gold rush and all those things, back in 40s, 30s and all that. Then it became, black gold. They talked about the crude, right? Petroleum and all that. Now today, data is becoming a gold, right? If somebody knows how to analyze the data in a very meaningful manner, you can unearth a lot of treasure which is just hidden underneath it, right? So if somebody doesn't know, right, data is like a dumb data, right? If somebody doesn't know how to dig the gold mine from the gold ore, whatever, right? It's something very similar. So the fact it says you have less of a chance of being killed by a falling piano than you do being adopted by Angelina Jolie. Okay, so it's just a quote. So it is like, if you can figure out, get some insights out of the data, that's what data science is all about, right? Actionable knowledge of data, correct? So moving on, what do the data scientists do, right? Who are data scientists? Person who is better pay. I mean, this is a very interesting quote, friends. Person who is better at statistics than any software engineer, and better at software engineering than any statistician, right? What we are trying to say, I think if you commonly look at it, friends, if you commonly look at, who are all the data scientists, I think even if you look at, requirements and all that, when they are hiring, they look at people who are holding a PhD from, statistics, PhD in mathematics, and or they have done some masters in, data science. These kind of lot of doctorates are getting into this, because if you look at business analyst versus data scientist, right, there is a subtle difference here. A lot of people get, uh, they get confused here. Business analysts also know how to use these algorithms, right? Whatever algorithms which we are going to talk about, they know how to use it. But they know how to use it in the sense they know how to use it for their respective domain. If somebody is expert in an insurance, right? Somebody is expert in an insurance, or somebody is good in retailing, somebody is good in, let's say, finance, and, fraud detection. Lot of domains are there. So the business analysts, they come with a lot of experience from a particular domain, yeah, and they know which algorithm is better suited for a domain, correct? But data scientists are, far more scientific in a way that they know how to optimize an algorithm, right? So they also know, and they are more scientific in nature, right? So they are very, very analytical too, and they are very, very scientific. They know how to optimize the algorithm. They go, they go and fix these things. So if you look at this definition, it says they are better at statistics than, because they have this mathematical or statistics bent. They understand the regression, linear regression. There is a question, what is regression? Now we'll come to that, yeah. So they understand what is regression. They'll not be looking at stars at that point, and they have this analytical aptitude, right? And they are good in software engineering. They are not like pure play statisticians. They are not like pure play software engineers either. It's a mix of both. Plus they are very scientific, and they understand the algorithms. They understand various algorithms and, optimization techniques and all that, yeah. So this is exactly where we are, friends. Data science from 10,000 or 1,000 feet here, right? They look at statistics, and look at, uh, visualization. Data science is like, statistics, domain expertise. They will have domain expertise also. Data engineering, they know the engineering practices. Advanced computing, right? Visualization, all the way till visualization, right? Because anything whatever you analyze, it culminates at visualization, right? Because that's when we kind of take the facts and present it to the forum, correct? We present it to the leadership, or the stakeholders, whoever it is, correct? So arsenal of a data scientist, what do they exact, what are their, what is their weaponry, right? What are the things which they take, right? They know how to architect it, right? Data architecture, they can use Hadoop. I mean, it may not be just Hadoop, but as big data goes hand in hand with data science, correct? So it is very, very, it becomes very, it's good to know Hadoop, right? A lot of data scientists, they are well versed in Hadoop, correct? So they know the Hadoop. There are a lot of optimization algorithms in Hadoop as well, correct? And the other thing is machine learning, right? Machine learning is also becoming a very, you know um, becoming one of the in things, because there are a lot of algorithms that gets done, especially in the supervised learning, unsupervised learning. Mahout is one of the tools that is provided by uh, Apache itself, right? Apache open source. So different machine learning algorithms is a daily work of a data scientist. It is very important for a data scientist to have a good grip over machine learning algorithms. Lots and lots of algorithms there. They must be quite adept to all these things, and they are fairly well versed in, tools like R, Python, or even SAS. Any of these tools, right? Because R is, all these are statistically significant, tools which supports a lot of statistical analysis and a lot of visualization as well. R is very good in visualization. Python is a great script, and it is becoming a de facto language for analysis, statistical analysis too, yeah. And machine learning, if you look at it, it's like it's a method of teaching computers to improve predictions based on data, right? It is a huge field with different algorithms for solving myriads of problems, correct? So there are lots and lots of machine learning, friends. One is supervised and one is unsupervised, right? So supervised is like, it is like the uh, the answers are given. It is with the training, the if you look at it, the categories of the data is already known, correct? So this is a kind of a machine learning algorithm. Unsupervised is it attempts to find appropriate category for the data. So it is even more what to say. We don't know in the beginning, right? So we find the appropriate category. Where does it fall into and all that, correct? So we get into that category. So coming back to this, my first algorithm for today, friends, um, decision tree. Decision tree, if you look at it, right? So I just want to give you a very small introduction about that. Decision tree is nothing but a tree-like structure, right? In which, like, we have multiple branches, right? And each branch represents some outcome of a test, correct? And each branch is called a leaf node, and it is having a label there, right? Decision. So what we do is, there is a, I'll look at this. So this is a training data, right? So each one has a root. It starts all the way from root, okay, goes all the way till leaf node, and it processes different rules, correct? Processes different rules here. Okay, now if you look at it, a student, right? Someone, who is, yes, if you look at it, right? Decision tree, I'm doing it for a student, correct? If somebody is like greater than 40, the income is low, and the credit rating, right, is fair, the class, is yes, right? Training, uh, uh, training data is like, training, this is the data, Jnaneshwara Rao, right? This is the data we generally, all these things. Training data is like, we have this historical data, correct? So we have this data. The more and more we feed in, right, more and more we feed in, the computers, or any algorithm for that matter, leave alone the computers, the algorithm becomes more and more stronger because the training set becomes more and more powerful, and the algorithm learns from that, correct? Okay, so one of the just give me a minute. So decision tree, right? The the one of the basic tenets of decision tree is the tree is constructed always in a top-down, recursive, divide and conquer manner, right? What we do is, the training examples, right? It is right at the top, right at the root node, correct? And all the attributes, if you look at it, right, it is all pretty much, you know, pretty much categorical, yeah. And input data is like, we just do it like partitioning it right from the beginning, correct? So what we do is, we go through different decisions. If you look at it, we make a like greater than 40, low, excellent, no. And again, the person who is less than or equal to 30, high, credit rating is fair, and the class is no, right? So this is all coming a no here, correct? So we make different trees. We start right at the top. It flows from the root all the way till the bottom, correct? All the way till bottom here. So we look at multiple things. They are all called classification rules, correct? We pass through different classification rules, then we come up with some conclusions, correct? We come up with conclusions. So this is exactly what we do, right, friends? So what we do is, what you have to understand is we have multiple branches, right? We have multiple branches. One key thing to understand in decision tree, which I want you to understand, is the, when would you stop making the decisions, right? Because you can go on till multiple levels, right? You start from the top and you can go on, correct? So when will you stop partitioning, right? You're basically creating multiple partitions here, right? So when there are, see, it's like, all samples for a given node, belongs to the same class. When you are doing a partition and there are no votes, right? So there are no more samples left for that particular condition, right? That is when you stop a particular partition, correct? So that's when you stop. So this is something I want you to understand. Otherwise, decision tree is fairly simple, straightforward. So you can go on breaking like this, this is a classifier stuff. Coming back to random forest, how many people have heard about this random forest? Heard about random fields? Okay, okay. Anybody else, friends? See, it is it similar? Yes, it's kind of similar, Shani. The point is, random forest, it is an ensemble classifier using many decision tree models. It is like a many decision tree models, right? So it is like ensemble means, you all would have seen an orchestra, right? You all would have seen an orchestra at some point. People all work in unison, correct? Ensemble. Fine. Similarly, I have multiple decision tree models that are coming out of, it works in ensemble, correct? The result from the ensemble is usually better than the result from one individual model, right? See, friends, it is like one thing. What I want to understand is, suppose you want to seek an opinion, right? You want to seek an opinion here. Should I go and buy the product, correct? So nowadays what we do, we just simply, we don't go to product just like that, right? We don't go and order something over the internet or even buy it over the shop, right? We first do some bit of research, correct? So what we do, we go to the internet and look for comments, correct? Even today, friends, today you want to go to a restaurant and eat, you don't make a decision just like that on the fly. You probably hearsay from the friends, you adopt something. Plus, you go to sites like Zomato, right? They do a lot of aggregation on different restaurants, correct? So you try to figure out, how many people have rated positive, correct? If there will be negative comments too, right? If 20 people have rated it positive, yeah, this restaurant has got great ambience and, great Italian cuisine, they come up with like, 20 great things, and 5 people would have, told something very nasty, you still make a decision and go there, correct? This is like an ensemble, right? I mean, it's a pretty crude example. What I want to state is the majority wins here, correct? Majority wins. So it is like each tree is grown to the largest extent possible. Decision is made by number of votes. Decision is made by number of votes from all of the trees, meaning that, collectively, correct? So whichever is positive or negative, whichever outweighs here, you will take things accordingly. Correct, friends? So features of random forest, if you see, sorry, I just forgot to flip this slide. If you look at your best friend needs, okay, you tell her whether it is, isn't she the main lead? Yes, no, you know, which age, isn't it so? But sample size matters too. I mean, which age? Correct, Arihant. Yeah, Arihant is saying sample size matters too. Absolutely fine. Just give me a minute. So this is what I was saying. Combined, the result is better than the individual decision tree models. Sorry. Yeah, I just want to say a few features about it, about the random forest. It is quite accurate that way because it is a collective result you are getting. It is quite accurate. It really runs efficiently on large databases. It can handle thousands of input variables. That's another good thing, right? And primarily, it is like, missing. It has an effective method to estimate, maintain the accuracy when the, it's fairly accurate because of we are looking at the majority here, right? So it is fairly accurate. And the next thing is you can also save the forest, whatever is used for future data. So it is a step higher than the decision tree, correct? So random forest is a preferred algorithm, I would say. It's one of the very famous algorithms, friends. Yeah, because it's an ensemble classifier, if you see from this diagram. Okay. So friends, moving on, I want to talk about association rule mining, correct? So how many people have gone to the supermarkets and all that? How many people have, you all, this is pretty familiar, right, friends? This is very familiar. Myself, okay. Uh, Before that, I just want to share, friends, one thing. Srini is asking, what is the data structure used for random fields in practice? Random, you mean random fields or random forest, Srini? Random forest, sure. So Srini, it can be like, it can access, as I told you, it can access any kind of database also, right? Because we are trying to make, it's the same structure as decision tree, but there are like multiple decision tree for every single decision, correct? So for the same decision, there are multiple things that are going to run, right? Like an ensemble, and we are going to pick the majority here, correct? Going by the number of votes. Anybody facing voice issue here? Pooja says voice is not clear. Is it better now? Okay, breaking. I'm so sorry, friends. I don't know why it is. My microphone, I can't keep it any more closer. It's almost in my mouth. Okay, Srini says it's perfect. Okay, all right. Sure, friends. I think some of you are facing apparently. I don't know. My network, I really don't know, friends. It seems okay at my end. I could be wrong here. 21 to 24, you can show it. Sure, Rahul. No, these are all the slides. 21, these are the ones. 22, 23, this is the one. Sure. All right. So friends, market, this is association rule mining, correct? So this is one of the, again, very sought after algorithm. Very sought after algorithm. Yeah. Just want to give you a perspective. So we all do extensive shopping, right? We use, let's say, eBay, Flipkart, Amazon, or even Alibaba for that matter, right? These are all very famous sites. Let's say you're buying a laptop, yeah, uh, probably a Macintosh. Let's put it that way. The site makes a lot of recommendation, right? As soon as you get onto the site, it says it makes a lot of recommendation. It says iPad, laptop accessories, and all that, right? When you're trying to buy this laptop, so they are all the recommended products such as headset, let's say infrared mouse, right? Have you come across these, friends? Recommendations. I mean, you all would have seen it in LinkedIn, correct? Right? The people you may know feature in Netflix. Arihan says Netflix, correct? Netflix and Google, Amazon, the books. You also want to read these books, correct? Right? Or how is this course useful? How this course is useful? Perfect. Akash, is that an example what you're quoting? Okay. So friends, these are all you all have experienced this, right? So this is all they. How do you think they are doing that? Any guesses, friends? How do you think they are doing it? How are they able to? Let's say if you do laptop, algorithms make life easy. Arihan says, fantastic, right? So what they do, friends? They try to, let's say, see, they do it on the fly, right? It is not like using classification concept, ML. Shanta is saying that, right? So what they do, even in, they do, even in LinkedIn, they recommend connections, right? Which most of them, right? At least in my case, friends, most of us, we find it quite appropriate, right? The people you may know feature in LinkedIn, it's quite kind of appropriate, right? That's right. So Suts says, uh, based on your history, then compare with others who have a similar history and go from there. Perfect, right? So now, um, the thing is, they try to mine the data. let me give you an example. They try to mine the data of click stream analysis, right? They can do this, and they can look at some patterns, right? They can discover the patterns, correct? If there are any similarity, they come up with recommendations, right? That's one way of looking into that. So they also figure out the buying behavior of various products, correct? They can do that, right? So one more thing is, how do you think the giant retailers, they provide discount, right? Promotion on group of product, right? Is it a random decision, or is it made on some research, friends? What do you think? When they do like discounts and all that, right? They do, you all would have seen. It is, of course, research, Arihan says, right? So they provide discount definitely on past purchase pattern, right? They look at, like, they mine the data, they identify the patterns, make decisions on even product placement in a store, right? You all would have seen, where the cigarettes are kept. It's um, where the cigarettes are kept, where the bread is kept, right? Where the milk is kept, right? And if you look at female clothing and all that, right? You will find kids wear, let's say kids wear, correct? And suddenly, you'll find some other products, the milk products, I'm sorry, right? It is just uh, it has been well thought through, right? Milk means, people also will pick up bread. We know this, right? We'll talk about, they also pick up, they are likely to pick up cereals, correct? They are likely to pick up cereals, friends. One thing I think, just a minute. All right, I just responded to a person who's asking me whether the webinar has started or not. Okay, let's talk about a shopping cart example, right? So let's say you are visiting a supermarket to buy products, correct? The basket has assortment of products like, juices, milk, window cleaner, detergent. Let me give you some random example. Okay, so if the retailer, for example, when you are billing, right, if they can analyze your basket, correct? They can very well determine the nature of the customer, right? Suppose you want to go to a small shop. Let me switch the context here. The shopkeeper very well knows you, right? In good old days, right, we all know people by faces and all that, right? We go to a shop, he exactly knows your preferences, right? If you buy, like, 5 liters of milk on every Friday, let's say, right? So you do it for 6 7 weeks, correct? You do it for 6 7 weeks, and the eighth week you don't go, let's say, right? And the shopkeeper, if he knows you personally, he's going to probably, ninth week or 10th week, right? If he spots you on the road, he's going to offer you discount or some other milk product, or he's going to at least inquire with you, right? Hey, what's happening? Why are you not turning up? I have some new brands. They try to do this. Um, Suppose you're buying from a giant retailer, right? These things are not going to be possible, right? You cannot expect human interaction at all, right? Considering the volume of the transactions, correct? Volume of the transactions. Fine. Just a minute, friends. This person is again. Just a minute. I'm just sending to the same person. He says I can't hear anything. All right. So like how do you think, folks like Walmart, Tesco, these guys are giant supermarkets, right? How do you think they understand their customers? It becomes just impossible if they do human interaction, right? They just don't have the time, and the kind of scale what they handle is phenomenal, right? And how do they do a profiling of the customer, right? How do they even do that? How do they increase the customer engagement, right? The only way to understand the customer is to analyze the data, correct? The big retailers, the data is the, that's the whole thing, right? Let's say you are analyzing the basket, you determine two products, right? Product A, product B, and all that, right, have been bought more number of times. So the customer who bought milk also bought cereals, right? So now you can handle the product placement very well. So you will try to, by looking at the basket, right, you can put these products together because there is a strong association. So that is how it has been researched. If you keep them close, right, you can actually stimulate the sales of these products, correct? But if you keep them, I mean, friends, do you you also would be seeing like there are certain times they also keep them as far apart, right? Sometimes the ones what they do is, if you go to a shop, you can. I mean, it's a beautiful concept, friends. Yeah, most of the times, we just go with the intention of buying things. We don't notice these things. What they do, it has been researched. Suppose the milk, right? Milk is kept in one side. They know that the guy is going to buy bread, right? Or cereals. They don't keep it close, right? They keep it apart, right? So what they do, they keep it apart though. Anyway, the customer is going to walk. The guy who's bought the cereal is going to go and pick up the milk. They know that for sure. So what they do, they keep it apart so that they are taken down, right? They are taken down a aisle, for example, correct? So they come across, where they showcase different products, correct? So the guy, whatever is the distance, no matter what, is going to go and pick up the milk, correct? So the customers will walk across the aisle where there is a display of different products, correct? So this is how, they also make the customers pick up. It's like forcing the customer to look at different products. Otherwise, they just go and pick up their stuff and walk out, right? So this is a way, they can also expand their, customer preferences and all that. There's a lot of research in this place, in this area, in this space, right? So I just want to, end this part with an interesting um, the association here. How many people know there is an association of beer and diaper? How many people have heard about it, friends, in this forum? Have you all heard about this? It's a very, very famous one. Beer and diaper. Yes? Awesome. Okay, I think so many. Okay. All right, that's very interesting to hear. Okay, there are, it's like this is a classic example of peculiar combo. Sambasivam, yeah, sure. I'll say that, friends. So this is a very classic example of basket analysis. It's like okay. Satvik says child will have diaper, father will have beer. Okay, that's fine. So this is a famous story that happened in way back in 1990, friends, right? When the retailers researched on the point of sale data, right? They researched on the point of sale data, right? Those days, that was the very prevalent system, right? It was found that during the weekend, the beer and the diaper were always bought together most of the time, right? The research results were out and they figured out beer and diaper are always bought together. So the people who bought beer, they also bought diaper, right? So what is the relationship here? Why is this pattern? So what is behind this association or relationship? What are the reasons? The thing is, there are things like, there are two theories, interestingly, right? The drinkers, right? Most of the fathers I'm talking about, right? They did not want to, you know, they did not want to, you know, uh, want the enjoyment to be curbed when they are drinking or watching televisions. So in order to reduce the trips to the bathroom, right, they bought diapers too. That is one theory. The others are like, when the fathers are sent on an, you know, when the wives especially, right, they say, okay, go and get, uh, especially the mothers, right, when they send their husbands, okay, go and get the diaper. Interestingly, at that point, they use that opportunity to buy their favorite brand of beer. There are like two different theories here, but nevertheless, it was a proven fact that, these two went together. They were sold together. Correct. So again, if you look at what kind of products are kept near the billing counters and all that, if you look at it, right, chewing gum, cigarettes, candy, battery. So again, this has been well researched, friends. These are all like, very, very essential things which we generally require. Leave alone the cigarettes part, because these are all, they are called random products, right? Random decisions rather. So they are all people, they are all I mean, to be precise, they are all called impulsive purchase items, right? So people just look at it and buy, right? Because it's not so expensive. If I, chewing gum and all, we don't buy or go to the supermarket and buy it, right? We just go see it, okay, oh, here it is, I'll buy it, right? Something like that. Unplanned purchases made by the customer, right? So these are all uh, you know coming under that. So moving on, friends, we spoke a lot of stories about it because I love this retail area. I did one project. So sorry to spend more time here. It's a popular, if you look at it, it's a popular, well-researched, discovering interesting relations between variables. Number of records, amount of records. There are a lot of customer buys onions and potatoes together, likely to buy hamburger meat as well, right? So this is basically the association rule mining. So moving on, friends, we will look into the linear regression here. Just a minute. So coming back to the linear regression, like I'll flip this slide. Okay, sample example. I want to just give you a very quick example. What is regression, right? Jnaneshwar? Regression analysis, right? Regression is something we do it over and over, right? We regress. We do it in the testing also, right? Jnaneshwar? Testing also, we do regression testing. Just want to define that term. Regression is like, we want to ensure that the application really works well uh, in multiple scenarios, and you want to regress it further and further, right? So let's take a sample example, friends. Linear regression, right? So suppose you are working for a let's say a real estate company, correct? And you want to predict the price of an apartment, right? You want to predict the price of an apartment. Now in that particular scenario, right, in that particular scenario, how do you go about it? Just want to know, like, what will be your thought process here? Like, there is a particular area and you want to predict because you are working for a real estate company, right? You want to predict the price of an apartment in a particular area. So what will be your approach? Collect data of past and analyze it. Arihant has a fantastic point here. You need to first collect, let's say you've collected historical data, correct? You have collected historical data, right? So the data, let's say, pertains to the price of the apartment, correct? With lots of different apartments, and you want to estimate what is the best price in that area, correct? Historical data, like SUDS also says that. Fantastic, right? So that's the way to go. Then can you please, like, friends, just I want to give you that. Let me just open, just give me a minute. Okay, just open something here, right? So can you help me with some parameters, like what will you um, when you say historical data, right? I know there is a lot of data you would have collected as part of price of the apartment, right? So what are all the parameters do you think that would influence the price of the apartment? Okay, Shanta says plot size. I'm just taking some of the plot size, floor, parking, hospital, schools, nearby, locality. Okay, there are tons of things coming up, right? Schools and all that, correct? Material cost. Material cost, okay. I think all of you are pretty experienced. Metro, yeah. Potential of the locality, fantastic, yeah. Type of the builder. All these are, like, credible factors, right? Thanks, friends. I think we already have too many things here, right? I just wanted a sample, just to get the whole thing going. Like, you also look at, for example, land price, right? Land price is, something in, the uh, in an elite place, right? Of course, the land price varies from area to area within a city itself. Sometimes the city, if you look at Manhattan, right, it is completely expensive, correct? And yeah, type of the builder, return on investment, there are various factors coming in from you. Thanks for that. So you're looking at the land price. You also look at the crime rate, right? Crime rate, for example, if there is a higher crime rate, you don't want to go there, right? because that one is a negative thing, correct? Number of schools, as you already mentioned, hospitals, and also, it's not I mean, someone mentioned metro here, right? Metro. So it's not like a slum, correct? Got a decent locality and different decent neighborhood and all that, right? And you also look at people mention landmark, right? Location, locality, potential of the locality, lots and lots of things are there, and what kind of amenities it has and all that stuff, right? So that could be technically n number of parameters, correct? So I can create a simple equation, friends. I don't want to, let's say price of the apartment. I'm just making it like very, very simple. B into, let me say, plot size, correct? I'm just looking at something. C into crime rate, you know, plus D into da 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 da. It can go on like this, right? This is a very, very simple linear regression rule, correct? Very, very simple. How to fix this variable? Number of variables. Yeah, I'm coming to that, Rehan. You can have any number of variables in linear regression, right? Any number of variables you can have, but you will have one fixed, you can have multiple fixed ones and one independent one, correct? So let's make an assumption. It actually relies on, in this thing, they're all, A into B into C into, I already put it like, right? A into B into C into, C into crime rate, B into, something else, right? Plot size, something like this, right? So linear regression, as a thumb rule, is asking. So I just want to answer this. It's a technique basically used for predicting the unknown value of a variable. In this case, the price of a real estate, right? From the known value of another variables, correct? So they are all the one which is dependent, right? Which is the dependent variable here, friends? Can you all tell me? Which is the dependent variable in this equation? Price of the apartment. Perfect, right? Now, independent variable is from the known value of another variable, right? These are all known values because I have picked it uh, from the historical data, let's say, right? So, dependent variable is a variable. It has to be predicted or explained in a regression model, right? The variable is assumed to be functionally related to independent variable, correct? So independent variable, if you look at it, it's actually how to put it? It's a variable related to the dependent variable in a in a equation like this, correct? So it actually helps in the regression model to estimate the value of the dependent variable, right? So these are all my independent ones. This is the dependent one, correct? So um, in our friends, though this sounds like it sounds very mathematical and all that, but in R it's quite simple. There is a linear regression. Linear model is the name of the function, right? If you use that, you're all set. So it is not so complicated as we think, correct? So we just need to define all these things, and you can very well get the linear regression done fast, right? So going back to this, so dependent variable changes when any one of the independent variable changes, correct? Other independent variables are kept fixed, correct? So linear regression is one of the most popular algorithm for prediction and forecasting, especially we use this in when there is continuous values, right? That's when we use prediction and forecasting. Jnaneshwar is asking what is the difference between prediction and forecasting. Can someone tell me, friends? Can someone in the class answer this? Forecasting is based on leads past data. Yeah, I think I'll go with forecast may go wrong. Prediction can also go wrong, right, Srini? Okay. Forecasting is the future, right? Plus or minus. Okay. Srini says plus or minus 10%. Weather forecasting. Okay. Nowadays, weather forecasting is becoming far more accurate, right? Harika says prediction is from historical data. Forecasting can be approximate observation to the future. I think, yeah, winning a bet is a prediction. Forecasting is with Pranay. Awesome. Winning a bet is a prediction. Yeah. Forecast. Prediction is guessing. Forecasting. Absolutely. Yeah. This is the closest thing which I can, which I feel it is quite correct. Prediction is more like a guessing, right? More like a guessing, of course, with, with it can be backed by strong algorithms, right? Forecasting is done on historical data, and both are very futuristic, correct? Both are very futuristic. Ravindran says prediction is what might happen based on the educated guesses. Absolutely. All these things are making sense here, right? Cindy, did you get your answer here? I don't know who asked me here. Okay. I don't know. Someone asked. Fine. I think moving on, friends. Let's move on from here. Just give me a minute. Sorry, friends. Yeah, sorry. So, so we were talking about regression, right? So this is my, I think we need to see a demo as well, quick demo. So I just thought I'll cover the clustering part, right? So before I come to k-means clustering, right? This is one of the algorithm, very, very popular one, right? So first of all, I want to understand what is clustering. What is your opinion about clustering, friends? Fantastic, right? So Harika, Shanta, everybody says grouping. I think that's uh, I'm not coming to supervised or unsupervised. Yeah, it is unsupervised, correct? Based on certain criteria, right? Grouping based on certain criteria. What we typically do, dividing the wider population into smaller groups, right? Dividing the data or anything, right? It's basically making smaller groups from a wider population, correct? Population is like, data I'm talking about, right? What could be the example here? Let me just give you some basic examples here. Let's say for a retail company, right? Retail company, that's the entire population, let's say, right? From that, we plan to get to the high value customers, right? So the entire customers is the population I'm talking about. We want to form a cluster on the high value customers, right? And lower value customers, correct? So let's take the example of Pizza Hut here, right? So they come up with different prices for uh, pizza, right? Based on locations, correct? Let's, something, forget about the Pizza Hut, friends. Let's take something closer to our heart, right? We all go to, different companies to work, right? So every company, right? They all do performance rating evaluation, right? We all hate that part. The people who get promoted, they like that. The people who miss the boat, they hate that, correct? It's as simple as that, because many companies, there is always a dissatisfied group of people, because very few get promoted and all that. So they give rating, correct? All the companies do rating, and they do like, 1 to 5, 1 being the highest or 5 being the lowest, and all the bell curve. Yeah, bell curve is one of the horrible systems, but yeah, a lot of companies are moving away from that, right? Now now one thing is, let's not come into that performance evaluation, but all the companies, they always form this cluster, right? They have this cluster based on high performers and low performers, right? So why do they need to do this, friends? Why do they need to do this? Any idea? Promote top performer. Fantastic. Allocate right projects to right people, right? Exactly. And promote them. Reward them, provide more opportunities, fixing high percentage. Yeah, thanks. So all these are valid points. Low performers, right? Maybe they maybe put them on training, or just give them a pink slip at some point, right? So these are all the potential things for a low performer. Maybe they may put them in a improvement plan and things like that. So why wouldn't, I have a question here, why wouldn't they target individual employees? Why do they always come up with policies for a group or a cluster, especially the HR, right? Not able to hear you. Sambasiva, are you okay now? I think there is a bit of background sound I'm getting at noise. Yeah, Pooja, there is a bit of noise at my end. Yeah, now it is gone, I guess. I don't know why. Is it gone now? It just came for a minute. I don't know where from. Okay, the friend, to okay, what I got was Arihan said not possible due to scale. Maybe easier to manage a group. Ravindran says, right? Correct. So it is. See, if you can manage things, people individually, right? Individually, that will be a very, very expensive exercise, right? It's going to be like too many, right? Individual level. It's going to be a very expensive exercise, and HR will die, right? Any organization, large organization is always with a cluster. Thousands of employees, they'll make groups of similar employees. Absolutely correct. Correct. Okay. And the other thing is, let's take the example of any supermarket. Let's say Carrefour, right? Supermarket. Do you think they create strategy for individual stores? Probably not, right? They cannot do that, right? It's very similar to what we are talking about, right? So in a cluster of employees, what we spoke a while back, the guy with the rating 1, right? They all get, they being the highest, right? They'll all get like 20% hike, right? The rating 2 will get 10% hike. This is how the policy will be written, right? And the last, you know, let's say the rating 5, people who are pretty bad, right? They'll be put through an improvement plan or some other strategy for them, right? So coming back to the supermarket part, right? Supermarket, it is like they cannot strategize for every single customer, right? They cannot do it for every every single store. So what they do, they look at, sales of they look at the sales of different stores, form a cluster, right? They can also geographically form a cluster, then create strategies for these groups, right? So creating a group of, let's say, population that are homogeneous in nature, right? When we create a cluster for high performers, let's say, we group all the people who are rating in 1 or somebody who is very similar in nature, right? This is how we do the clustering, correct? Similarly, and basically, for high performers, we consider people who do delivery on time. I'm just giving some of the common characteristics. They go the extra mile, right? They demonstrate tremendous commitment, things like that, right? So if you look at any individual in that cluster, okay, very, very similar compared to others in different cluster, right? So process by which it is done, there will be high intra-cluster similarity, right? Do you understand, friends, what I'm trying to say? Whatever I'm saying is a intra-cluster similarity will be high because it is homogeneous in nature, whereas low inter-cluster similarity. Low means like there'll be a remarkable difference between a guy from a uh, let's say high performing cluster to a mid-level performing cluster, right? There has to be a definite difference there. So it'll be a very low inter-cluster similarity, correct? Sure, friends. Are you all getting it? All right. Friends, there is a big definition posted by Srini. I just want to read it because I find it very insightful. What he says is a prediction is a definitive, specific statement about when and where an earthquake will strike. A major earthquake will hit Kyoto, Japan on June 28th. Let's say he has put it like this. Whereas a forecast is a probabilistic statement, usually over a longer time scale. There is a 60% chance of an earthquake in Southern California over the next 30 years. Thanks for sharing, Srini. Good. That was very insightful. Okay. So let's look at k-means is one of the great algorithms, friends. So just give me a minute. I'll pull the R. and we can, as I told you, this k-means clustering, right? It has got high intra-cluster similarity, low intercluster similarity, also finding natural groupings among objects. So why do we want it? Why clustering? I think we already know the benefits, right? Sometimes, partitioning, market segmentation could be one of the goals here, right? Segmentation could be one of the goals. And techniques is like, we do organizing the data into clusters. So it also becomes very easy, right? By clustering it, because we are clearly defining a partition. And the the process of k-means, I just see whether anything is there. K-means, yeah, it's there. The process, it's actually number of groups dissimilar as possible from one group to another group. This is what I was telling, intercluster, but as much similar as possible within each group, right? So this is what we are trying to say, right? So group one should be similar as possible, the objects within group one, right? Whereas there should be much difference between objects in different groups, correct? High intra, Jnaneshwar is asking what is high intra, right? So the point is high intra is like, friends, um, the objects within this, right? It's like, the high performers who we clustered, right? Who we clustered, the high performance is actually the list of high performers. They will all be very similar in nature. That's what we are trying to say, right? Correct? And similarly, the people, a high performer here, let's say group one, intra means within, exactly, right? Let's say inter is group 4 and group 1. I take a high performer here and a low performer here, right? Is a low performer cluster, right? There should be distinct difference, tremendous difference, right? Like within and between groups, exactly, Shilpa, right? So there is a question. K refers to the fact that, this algorithm is going to, someone is asking what is K means, right? K refers to the fact this, actually this algorithm is, to break the entire cluster into K different clusters. That's what it means typically, right? So we need to specify how many clusters do we need, and, is it 4 or 5? There is nothing like, but the value of K, right? So let's say we need to create 3 clusters, right? How do we move forward? Correct? How do we move forward? Like, we need to create 3 clusters, right? So it is like, we look at, I'll come to the demonstration aspect, friends, shortly. Okay, there is a demo. Sure, I'll come right there. Just let me, okay. I have something, let me clear this all. I was just putting that to see whether, okay. So this is my data. I have some workers.txt. Okay, this is my demo, friends. So what I've done, this is where I was, workers.txt. I just want to show you the data set before I, uh, okay, Srini is asking, before that I'll just answer this question. Do you initially decide? Okay, it's a great question, Srini. We can't decide. See, what we do is, there is a concept called elbow curve. I'm not coming to that, but, it can very well tell you by plotting all these clusters together, right? I can run it for, 3 clusters. I can run it for 4 clusters, 5 clusters and all that. There are other methods too, right? How to find the optimal number of clusters, right? Okay, how many clusters? Manish is also asking the same question, right? So I can have different, you know, with different clusters I can run. But if you look at the, there is a method called elbow curve method, right? That's very popular there, right? So what it does, it actually starts curving out, right? So it is like an elbow, right? It starts curving out like this. If I can draw it and show you, just give me a minute. So at that point, right, you know that, it is flattening it out, right? It'll keep coming like vertically, right? Just give me a minute, friends. I'll just see whether I can pull the paint. Um, just a minute. sorry. Yeah, right here. Okay. So you will find if it is a graph like this, right? Let me use something. I'm very bad in drawing, friends. Let's say, did I use ink? Color picker. Okay. Let me choose some red, and this one is a pencil. Okay. Thank you. So click, yeah, sure, Srini, thanks. So if I have like, number of clusters, right? Sorry, my line is so bad. Let me draw it this way, right? So this is my number of clusters, right? 1, 2, 3, 4, 5, and all that, right? I have this number of clusters. Okay. So what I do is, if I, um, this one, right? If I start plotting it, right? It starts coming in like this, right? K-means. If it's like, 1, 2, it comes, keeps dropping. At some point, it flattens out. It becomes like an elbow, right? It becomes like an elbow. Suppose it flattens out at number 3, then, okay, 4, 5 and all will give me more result, right? Srini says y is 1 by x curve. Okay. Sure. So number of clusters, right? So if it flattens out here, right, I'm better off going with number of clusters to be 3, correct? So this is what I was trying to tell you. Just a minute, friends. I'm getting a message here in my uh, okay. All right. So let's go back to the demo. Sorry about that. So this is my data set, as I told you. Very, very simple data set. Yeah, here is my data set, Arihant. What I've done, this is for a, let's say for an organization with workers, and this is their score. Score meaning, there is an employee score, right? Higher, higher means they are better off, right? Out of 100, correct, Arihant? So somebody, I want to kind of cluster them, right? I want to kind of cluster them. So I'm using, first thing I want to read the table, right? So I'm loading them, loading the data from this location, what I'm showing you, correct? So next thing is I want to um, just get this, k-means, right? K-means is a function here, right? So I want to give as number of clusters. How many clusters I'm creating, friends, in this case? 4. Yeah, right? K-means cluster. If you look at it, right, it, just give me a minute. Okay, the way before that, there are like, we always give, let's say if it is, if I make it 4 clusters, right? What internally happens with k-means algorithm is it picks, right? 4 data points, right? If I want to create, let's say 4 clusters, right? It picks 4 data points randomly, correct? So this is called centroid, right? Centroid, or let's say seed, whatever it is, right? So there are 4 seeds. Then in the first iteration, right? Internally, how the algorithm works is what I want to tell you. The distance between the data point to the seeds is calculated, right? So it starts plotting it, right? So based on the proximity, right, to the nearest seed, right, each of these data points will try to align itself, right? Next iteration, next iteration. At some point, I mean, what I'm trying to say is, let's say here is my, uh, let me just, here, if this is what is my thing, please excuse my diagram, right? If there are 4 clusters, right, it may randomly put something here, 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 and here, right? Then it starts plotting here, 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 and all that. Again, here, here. sorry, let me draw something legible, right? It starts plotting here, and it may plot something here and here, right? Red ones. And again, it may plot something here, 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 and all that. Then let's say this one here. Fine. So it starts plotting near the centroids, right? Then it starts forming, the distance between the data point to the four seeds is calculated, right? Based on the proximity. When it is, when a high performer, let's say, when a high performer is closer, right? Because we are looking at some similar characteristics. The more and more similar they are, right? We want to cluster them together. Suppose this is a high performer, right? Although it is the second iteration, it will try to pick it up like this, right? It forms a cluster, correct? So it keeps changing, until it settles down, so that the basic thumb rule of intra-cluster similarity is very high and inter-cluster similarity is very, very low, correct? So it may make few iterations until it settles down, right? So it'll probably, it gets aligned, then it starts settling down, correct friends? Are you all clear what's happening? So how is created? I mean, right? Arihant is asking how four centroids is created. Arihant, it is random. To start with, it is random. It is picked randomly. Then we start plotting it here and there, right? Then even though a top performer may have been plotted here, so next time it will move it closer to this high performing group, correct? This is how it will happen. Yeah. Okay. So now coming to this, what I'm saying is D1, D2. This is just a way to, what I've given is based on this. I've given if you carefully look at it, right? I've given a value for this. Where do they exactly fit in? Friends, do you get what this value is? Do you all know what this value is? Can you take a guess? Exactly. Sheeny gives a fantastic answer. It is the cluster value, right? Where do I want to cluster them, right? Is it in the first cluster or second cluster, right? Correct? We are talking about four clusters. This is a cluster value, right? So I'm putting that, I'm just binding that to a data set here. 1, 2, 3, 4. That's all, right? All of them are pretty much coming in here, right? I have 50 employees, right? So now what I want to do, I bound them, right? If I want to plot them, right? If you look at it, right, it may appear a bit weird here, but it's like all the, if you look at it, right, it's fairly, you see the four colors. Let me just maximize it. Correct, friends? See, the green ones are the bottom performers. Let me put it that way, right? And these guys are somewhere intermediate, 60 to 80. This is the top cream, right? So they are all potential. What to say? They have to be promoted, correct? They have to be promoted, correct? This area, they all become potential candidates for promotion. Just let me use this. This is the area, right? This is the area. And similarly, these guys are like, fairly, they are in the intermediate. In any organization, friends, you will have this kind of combination, right? You will have the top cream and you'll also have the bottom performers. Incidentally, rather, the too many bottom performers here, which is also not good, right? So I can probably have one more cluster to just separate out. If I do five clusters, right, it becomes like, the people who are in this ballpark, right, they are all very bad, right? These guys are, these two clusters are not so good, right? Just wanted to demonstrate that to you because there is a bit of inter-cluster similarity is not so great, right? It's very close, so it shouldn't be like that. So I need to have this cluster little away from this one, right? And these two are like, predominantly the medium level people, right? They'll be the large section generally, correct? Uh, Sorry, friends. Yeah, minute. Okay, sure. Okay, so friends, that's, I just want to go back here. Have I missed out anything? Plot, yeah, points. Have I missed out any? That's pretty much it, friends. I wanted to show you that. And how to identify each circle as a specific employee. No, that's what I've done, Harika. Like what I've done, this is what I've done, just to identify each person. You can, I have not given a label in that place, but in that cluster, right, what I've done is there are like, Rahul is asking, how do we determine, sure, how do we determine in a particular scenario which one of these five algorithms, any other approach to use to big data problem, any metrics? Rahul, the thing is, as I told you, we have picked up five algorithms. I'm not saying this is the best or something. To be very fair and straightforward here, there are umpteen algorithms in data science, right? Even for clustering, you have different, even for regression, right? You have different algorithms. There are gradient regression. There are a bunch of regression algorithms. How an organization works, Rahul, is they want to have a combination of algorithms and they look at different aspects, how it is, how it is coming close to their expectations, and they go with the algorithms, right? They go with the algorithms, correct? So it is not like, it is, this is the best and all that, but sometimes they take a decision based on, the accuracy of the algorithm, right? Because some algorithms works better in certain data points and things like that, right? They look at, basically the accuracy will be a great determinant in the deciding the algorithm. Every time in R, does the points in a cluster change mean? I mean, every time we have a different shape. Uh, Shilpa, the point is every time, I would say that, number of clusters would mean a lot here. Number of clusters would be a determining factor. So if I make 5 clusters, right, it will be a different story. If I make 6 clusters, but as I said, the number of clusters, you need to take the elbow curve, or there are other formulae to arrive at the number of clusters where it is flattening out, as I told you. So that becomes the ideal thing for you, so that it gives a clean depiction of your clusters. But of course the shape will change, Shilpa. It can change because the way you are going to cluster the whole thing. Arihant is asking, any book you suggest work on algorithm for big data? Uh, there are again data science. There is a essentials, data science essentials. There is a book, Arihant. That's something I have read, and of course there are a few books on R itself. But to me, for R, the best help you can get is from the R community itself. If we put k constant, does the point always fall in the same Uh, no, no, K is the number of clusters, right, Shilpa? The thing is, what I'm trying to say is, if we are, see, it is all, the way you've designed the data set, right, Shilpa? This data set, this is the first cluster, right? Second cluster, third cluster. This is how we are doing the cluster. This is how we are getting the cluster. The K means is actually splitting the clusters based on these values, based on the performance score, whatever is the score, correct? Sure. Okay. Yeah, thanks. My pleasure, friends. I think I've shot over 20 minutes nearly. Yeah. Uh, Share the statistics books. Jnaneshwar, I would say statistics essentials. You can, not to trivialize, books and all that. You can go to this, just not getting the name here. The one of the famous guys, who puts the video and all that in. Mm, There are umpteen blogs, friends. I just don't have it in front of me right now. But Khan Academy has a lot of stats. You know, uh, they have a lot of statistics. Small time things. But you need to have a statistical mindset for sure. Right? Khan Academy has one. But even again, I'm not trying to market this course, but Edureka, right? People who are taking up data science, they are also given a primer course on, statistics. So that course, I found that to be very useful. Harika is asking, what is the scope of all these algorithms in business analytics? Harika, phenomenal. Phenomenal scope is there. And friends, let's not forget it, right? There are more and more, data is coming in, right? As long as the data is there, there's going to be more and more work for the analysts, right? Things are not going to change, right? Lots of analytical uh, thing is needed because we are going to process more and more data. How we know which algorithm is used which situation? Nyaneshwar, that's a very tough question. In the sense, there is no uh, straightforward approach that which algorithm. As I told you, regression, you have 5 different algorithms, right. You need to find out what is the accuracy, because based on the data set, right, some, because you may still want to use some algorithms and look at the accuracy aspect, right. If something is, because for certain data, right, it's not that best algorithm is linear regression all the time, right. You may look at different combinations of algorithms and apply it accordingly, so that whichever is coming closer to your expectations, that will be the algorithm. Basics I should be aware before any data science program. Prashant, it's not like somebody who has a general analytical aptitude, right, it is good enough. But somebody needs to understand these algorithms and all that to a fair extent, correct. So online, Prashant, you can go to the Khan Academy, if you're planning to join a course or something. I mean, if you're planning to join a course, some of the providers, including Edureka, right, they give you statistics, basic statistics, refresher course, a free course. You can use that. Or otherwise, if you want to do a self-paced study, you can go to Khan Academy and take statistics. How would a software engineer has an edge? Raghav, this is a very software engineer status edge over a statistician, or I mean, Raghav, this is, see, data science is a job, right. It is one of the professions. It is not going to kill a software engineer, nothing like that. All of these things will coexist, that is for sure, right. It is not like this will have an edge and all that, because more and more data, more and more analysis. So of course software engineering will have to thrive on, right, because there are a lot of software engineering practice which we are required to do, right. So there's nothing like data science will eat away those things. So it'll all coexist, I would say. My last question, Arihan says, do guys who has MBA, will this help them? uh, MBA in, yeah, probably, Rihant, something like, two dimensions, not two dimensions, what to say, some domain expertise, right? Domain expertise, it can all help them, right? Suppose you are, Arihant, let's say you come from retail, MBA in retail, right? So from that aspect, I can say that, domain, from your domain expertise may help in becoming a data scientist, right? Manish says this cluster graph is two dimensional. So for K means we can have two attributes. No, no, no. It is not two attributes. Oh yeah, okay. I can have more attributes as well. Yeah, this one is yes, correct, Manish. Nyaneshwar says I am in Java for 6 years. Can I start trying as a data scientist? Yes, nothing can stop you, Nyaneshwar. You can do that. How many, how are openings in data science comparing with business analysis? There are multiple things, Varalakshmi, right? Openings is like, I think comparing, definitely, both are different, because data science requires bit of domain knowledge, but business analyst, right, you need to be strong in a particular domain. That's how it is, Varalakshmi. That's how I see it, right? So both are going to be available. Certification courses to become a data scientist. You can actually, Harika, you can take, again, I'm not here to market any course, but Data Science Essentials is one of the course offered by Edureka that I know, because I take those courses too. So, but there are other providers too. I leave it up to you. But data scientist, the certification course could be one of the, it can provide you the start, but it cannot be the only thing. But it can give you a decent uh, jump start. Sure. So friends, I hope I was able to do some justice. Hope you found the session useful. So thanks for your time, and I'm glad that a lot of people asked a lot of relevant questions and very valid points here. I got to learn a lot of things today, especially on the forecasting and all that. Thank you so much. And friends, one last request. Once I close this, please provide the feedback, right? Please provide the feedback and towards the once I close the session. Yeah, please do that, friends. Thank you so much.